Hello class. Today we're going to have a quick discussion about what exactly is a p-value. Now, with the invention of software, a lot of the procedures for hypothesis testing that we do today by hand in an intro to statistics class is something that you don't really need to do anymore. Now, the reason we do it in an intro to statistics class is because we want you to basically get your hands dirty, so you understand how exactly you do hypothesis testing and what is it used for. But in reality, most of the procedures that we do today can be done by software very quickly, and you don't really need to perform the entire procedure. But you do need to understand how to interpret the answer that the software is going to give you, so you can make a decision on whatever it is that you're interested in making a decision on. All right? So one of the things that most software give you that give you an output for is something called a p-value. Now, what exactly is a p-value? Now, p-value stands for probability value. And the p-value is basically the probability value, and it is the probability of observing a sample value that is as extreme or more extreme than the value observed. So remember, every time you're doing hypothesis testing, what you're basically doing is you comparing that sample value that you obtain to that population value that you already have. So a p-value tells you how extreme is the probability of seeing that sample compared to that population number. Now, the simplest way to look at your decision process for a p-value is to follow this. You're going to reject HO if the p-value is less than your alpha. So if your p-value is less than your level of significance, then you're going to reject HO. Now over here, I have basically an idea so you get why you want to reject HO. So imagine that you have an alpha, and let's just put a number there of 0.05. But you run your data and you have a p-value of something like 0.03. In this case, the p-value is less than your alpha. So if your p-value is less than your alpha, you're going to reject HO. Now, the reason you're going to reject HO is because the sample information that you have is significantly away from the center. It's farther away, the probability that this is correct is farther away from the center than your alpha. And notice that again, this could be on the high side or it could be on the low side. So if it's on the low side, you can say fairly conclusively with something like this that there has been a change on the low side. And if you see something like this on the high side, that there has been a change on the high side. Alright? That's why you can reject HO, because the p-value is more extreme, the probability value of your sample is more extreme than the alpha that you have selected. Alright, if instead you end up with something like this, imagine that you have an alpha, again, of 0.05, but you end up with a p-value of something like 0.11. Now notice that in this case, the p-value is greater than your significance level. Because the p-value is greater than your significant level, you do not have sufficient evidence to reject HO, so therefore you do not reject HO. And that basically means that you don't have enough evidence that the sample information that you collected has a lower probability than the alpha that you have selected. Therefore, the number that you have, your probability value, is lower than your alpha, so you do not reject HO. Alright? Now this should give you a pretty simple way to interpret a p-value in any occasion where you are comparing a population information to a sample information. Okay? Without having to use the entire process for hypothesis testing. I hope you've learned some statistics today. Have a good one. Professor Choi is here.